Hello student, in today's session we have to start chapter number 15, structure of atoms and nuclei. From this chapter we have to start article Bohr's postulate. So different theories was proposed to explain the nature of atom, and one of the theory proposed by the scientist Bohr. So from that Bohr's atomic model we have to cover Bohr's postulate. So today's article is Bohr's postulate. So here we have to cover important three Bohr's postulate. The first Bohr's postulate. So postulate 1. Now what is postulate 1? Basically this postulate is about a circular motion of electron around the nucleus. So you know that structure of atom, central part, nucleus, in that protons and neutrons are there and electrons are revolving around the nucleus in a circular way. So we already learned a topic circular motion. In that, to maintain circular motion, a centripetal force is essential. In case of electron, the centripetal force is provided by which force that we have to write in the postulate 1. So here you note one thing here. For circular motion of electron around the nucleus, centripetal force is provided by electrostatic force of attraction between positively charged nucleus and negatively charged electron. So I can write here centripetal force. Centripetal force for revolving electron is provided by electrostatic force. So we get this condition. Now I can write here formula for centripetal force. We know the centripetal force is mv square by r. Electrostatic force, I consider here a simplest atom, and simplest atom is hydrogen atom. So I consider here hydrogen atom and then I write everything for that hydrogen atom. So I can say that in an hydrogen atom, for circular motion of electron around the nucleus, centripetal force provided by electrostatic force. So centripetal is given by this, and electrostatic force we get by Coulomb's law. You know that Coulomb's law is, by Coulomb's law, force, electrostatic force is Q1 Q2 divided by R square. This constant into this Q1 Q2 divided by R square. Now here electrostatic force for electron I can write this constant 1 upon 4 pi epsilon 0 as it is. Charge on electron multiplied by charge on nucleus. In hydrogen atom only one electron, only one proton. So charge on proton and electron having a same magnitude. So product of magnitudes of charge E into E square divided by R square. So we get this formula. So if I consider other atom other than hydrogen, if I consider any other atom, then I can write here Z E square. Z is atomic number. Atomic number into this E square we can write. Okay. So we get here formula for postulate 1. Similar manner postulate 2. Bohr's postulate 2. In postulate 2, Bohr written when radiating electron does not radiate energy. Sorry, revolving electron does not radiate energy. So you know that electron is accelerating charge. According to this Rutherford, all accelerating charge radiate energy. If electron is an accelerating charge, definitely it radiate energy. According to Rutherford, energy radiated by electron is means electron radiate energy continuously. So the spectrum of energy is a continuous spectrum. But later on it is found that the energy spectrum is not continuous. It means that electron is not radiating energy continuously. So in postulate 2, Bohr written when it radiate energy and does not radiate energy, and postulate 3 it is written when it radiate energy. So listen, postulate 2. Postulate 2 is electron revolve only in those orbit without radiating energy for which angular momentum is integral multiple of h upon 2 pi. So I can write here angular momentum angular momentum is equal to integral multiple of h upon n, means h upon 2 pi. So angular momentum I can write L is equal to nh upon 2 pi, this formula we get. Or we can write this angular momentum by a formula mRV. So we get mRV is equal to nh upon 2 pi. So this is the formula. Okay, this is the formula for second postulate. So here only instead of angular momentum I written here mRV. So by second postulate we get angular momentum is equal to integral multiple of h upon 2 pi. Now here you remember second postulate, I repeat it again, electron revolve without radiating energy only in those orbits for which angular momentum is integral multiple of h upon 2 pi. So in postulate 2 it is written when it does not radiate energy. In postulate 3 we have to write when electron radiate energy. So postulate 3. Now in postulate 3 we are writing when electron radiate energy. Now pay attention. So when we are considering here different orbits, so you know that atom, structure of atom, central part nucleus, electron revolving around the nucleus in different orbits. Now I consider that an electron which is in the higher energy orbit and this electron want to come in the lower energy orbit, then it has to emit its excessive energy. You know that energy of electron in outermost orbit is more as compared to the inner orbit. So when outer orbit electron want to jump into the inner orbit, then that time extra energy electron has to emit, and that energy emitted by electron is in the form of photon. So we can write third postulate. Electron radiate energy when it jump from higher energy orbit to lower energy orbit in the form of photon, and the energy radiated, you remember this, energy radiated is equal to the difference in the energies of two orbits. So I can write here energy radiated is equal to difference in the energies of two orbit. So energy of nth orbit minus energy of pth orbit. E means this is nth is the outer orbit and this is inner orbit. So if we take the difference of these two, we get the energy emitted by the electron. Now this energy is emitted in the form of photon. So energy of photon, we know that it is h mu. So we can write h mu is equal to En minus Ep. So this is the formula by third postulate. So we are written three postulate. In first postulate we are written centripetal force provided by electrostatic force. Second postulate, electron revolve without radiating energy in an orbit for which angular momentum is integral multiple of h upon 2 pi. And in third postulate we are written it radiate energy only when it jump from, electron radiate energy only when it jump from higher energy orbit to lower energy orbit, and energy radiated is equal to the difference in the energies of two orbit. So that's it. So here you remember one thing. So this n is 1, 2, 3, 4. This n is also called as principal quantum number. In this formula, the n is the number of orbit. It is also called as principal quantum number. Now we have to learn next article. Hello. Now next article from chapter 15, structure of atom, and it is radius of Bohr's orbit. So radius of Bohr's orbit. Now pay attention, or we can write here radius of orbit basically. Now I consider here electron is revolving, electron having a mass m is revolving around the nucleus with the radius r. So we consider electron is revolving. I consider here the simplest atom hydrogen, and then we derive this derivation. So for hydrogen, you remember, for hydrogen Z is equal to 1. So I consider hydrogen. And then by Bohr's first postulate. So first postulate is centripetal force is equal to electrostatic force. Now here we can cancel the common term. This r and 1r from r square get cancelled. So we get mv square is equal to, I write e square into 1, e square divided by 4 pi epsilon 0 r. Now here I can write v square by transferring m to this side. Hence v square is equal to e square divided by 4 pi epsilon 0 m into r, equation number 1. Now this is velocity square by Bohr's first postulate. Similar manner we can use Bohr's second postulate and we obtain v square. Also by Bohr's second postulate. Second postulate is angular momentum mrv is equal to integral multiple of h upon 2 pi. Now I can write a formula of v by using that. I can write it here. So I can write v. So v is equal to, I can transfer m and r to that side. So we get n h upon 2 pi mr. Equation, no, I can square this equation and then give the equation number. Squaring both sides, we get v square is equal to n square h square divided by 2 square is 4 pi square m square r square, equation number 2. Now see the equation 1, this is equation 1 and this is equation 2. Both the equations are equation of v square. Means here we can say that their left hand side is same. So right hand side is obviously same. Or we can equate equation 1 and 2. Hence equating equation 1 and 2. Now after equating, what we get? Now see here this, or I write it this one first. E square divided by 4 pi epsilon 0 mr is equal to this n square h square divided by 4 pi square m square r square. Now after that we have to cancel the common term. So common is here 4 pi and 1 pi only from this pi square get cancelled. This m and 1 m from m square get cancelled. This r and 1 r get cancelled. So here e square divided by epsilon 0 is equal to n square h square divided by pi m r. Pi m and r. Okay. We have to write formula for radius because heading be given radius of the orbit. So radius, this r we shift to this side, e square and epsilon 0 to that side. So I can write r is equal to, so we get here n square h square and this epsilon 0 here divided to that side multiplied. So epsilon 0 n square h square divided by this pi m and this e square to this side is divided here. So e square. And this is expression for radius of Bohr's orbit. Now here, in this formula, we can write here r is equal to epsilon 0 h square divided by, I am writing epsilon 0 h square divided by pi m e square. Pi m e square into this n square. So I can consider this epsilon 0. The value is fixed, means it is a constant. H is a Planck's constant. Its value is also fixed. Epsilon 0 value 8.85 into 10 raised to minus 12. H is 6.63 into 10 raised to minus 34 joule second. Pi 3.14. Mass of electron 9.1 into 10 raised to minus 31. E charge on electron 1.6 into 10 raised to minus 19. Everything is constant in this bracket having a fixed value. If I substitute everything, or means this is a constant I write here. So I can write here constant multiplied by n square. So we get this formula. Or we can write here r proportional to n square. So r proportional to n square. So r is the radius of Bohr's orbit, proportional to n means principal quantum number or number of orbit, obviously, n square. So we can write the conclusion. Therefore, radius of Bohr's orbit is directly proportional to square of principal quantum number. Question may be asked in examination, obtain expression for radius, you have to write up to this. May be asked, show that radius of Bohr's orbit is directly proportional to square of principal quantum number, you have to write up to this. Also, by substituting all constant, we write, if I substitute constant means epsilon 0, h, pi, m, e square, everything if we substitute, then we can write this value is r is equal to, it is coming 0.53 into this n square. So this value is in angstrom unit. Okay, this is in angstrom, or we can write like this way also, angstrom. Therefore, radius of Bohr's orbit, for Bohr's orbit n is 1. N is 1. So if I substitute n is 1 for Bohr's orbit, n is 1. Hence r is equal to 0.53 angstrom. So this is a radius of Bohr's orbit. Listen, in examination, if the question is asked, they ask find out what is the radius of third orbit. So you can use this relation. First orbit having a radius is 1. Third orbit radius is, and you have to substitute 3. 3 square is 9. 9 times of this one is the radius of third orbit. Similar manner, you can find out radius of any orbit by using this formula. I hope everyone understood this. So this is very important article. Radius of Bohr's orbit. Hello everyone. Next article from chapter 15, structure of atom and nuclei, is energy of electron. After this radius of orbit article, we have to learn a new article, and it is energy of electron. In this article, what we have to do? We have to find out kinetic energy of electron, then we have to find out potential energy of electron, and then we have to add kinetic energy and potential energy. We get total energy. So I told you the procedure of this article. Now let me find out a kinetic energy. For that, I consider one electron is revolving around the nucleus. I consider here simplest atom and hydrogen atom we are considering, for which Z is equal to 1. So for hydrogen, Z is 1. So consider electron revolving around the nucleus. Then by Bohr's first postulate. So by Bohr's first postulate, centripetal force is equal to electrostatic force. So here we get this formula. Now here, by using that, I have to write kinetic energy. So this RR get cancelled. So we get mv square is equal to, so E square divided by 4 pi epsilon 0 R. Now mv square we get. You know that kinetic energy is half mv square. So I can multiply it here half and here by half. So we get a formula of kinetic energy. So multiplying both sides by half. So 1 by 2 mv square is equal to E square divided by. So 1 by 2. 2 into this 4. 8 pi epsilon 0 R. Now here, this is a kinetic energy. Hence I can write kinetic energy is equal to E square divided by 8 pi epsilon 0 R. So equation number 1. So we get kinetic energy. Similar manner we can find out potential energy also. So potential energy. potential energy is. So here you remember one thing here. Potential energy we can write electric potential by a formula, electric potential into charge on electron. Electron potential multiplied by charge on electron. Electron potential we can write 1 upon 4 pi. I think this is visible. Oh yes, it's visible. 1 upon 4 pi epsilon 0. Then E by R multiplied by charge on electron is minus E. So after solving this, we can write potential energy is equal to, hence potential energy is equal to E into minus E square. So I can write minus here, this E square. Then this 4 pi epsilon 0 R. 4 pi epsilon 0 R, equation number 2. So equation 2 is the potential energy, equation 1 is the kinetic energy. We have to add both the energies, we get total energy. Hence, total energy of electron is E is equal to kinetic energy plus potential energy. Now here kinetic energy is this E square divided by 8 pi epsilon 0 R minus. Why minus? Because potential energy having a minus sign here. So here minus is coming. This E square divided by 4 pi epsilon 0 R. Now we have to select common terms. Now what are the common? E square is common. Then this 4, I can write 4 pi epsilon 0 is common. Okay? And then here 1 by 2. Or I can write only pi epsilon 0 common. E square divided by pi epsilon 0 R. Then here we get 1 by 8 and here minus 1 by 4. 1 by 8 minus 1 by 4, I can multiply it to divide by 2. So 2 by 8. So 1 minus 2 minus 1 divided by 8. Divided by 8. So here E square divided by pi epsilon 0 R. So here we get minus 1 by 8. So this minus 1 by 8. So I can write it here minus E square divided by 8 pi epsilon 0 R. So this is what total energy. Now in this total energy we have to substitute this radius of Bohr's orbit, which we already obtained in the previous topic. But radius of Bohr's orbit is, I write. So R is equal to epsilon 0 n square h square divided by pi me square. So this is the formula of radius that we have to write it here. Hence, E is equal to, so I can write this E square divided by minus E square divided by 8 pi epsilon 0. And this 1 by R, I can write it here. So this is R, 1 by R we have to write pi me square divided by epsilon 0 n square h square. So I think this is visible. Okay. Then we have to cancel the common term. This pi get cancelled. So minus m. Then E square, E raised to 4. 8. Then epsilon 0 square. N square h square. This is formula of E. Now this is expression for energy of electron. E is equal to minus me raised to 4 divided by 8 epsilon 0 square n square h square. This is expression for energy. Then after that, I can write same formula. E is equal to minus m e raised to 4 divided by 8 epsilon 0 square h square. And then this 1 by n square I am writing here. I written all the constant in a bracket. This m is constant, e is constant, epsilon 0, h, everything is constant. Only this principal quantum number n I written to that side. So here this is constant. So I can write here this constant into this. So minus into this constant, and constant I write into this 1 by n square. So I can write it here E proportional to this 1 by n square. Question may be asked on this article, obtain expression for energy, you have to write up to this. Show that energy inversely proportional to square of principal quantum number, then you have to write up to this. Energy of electron is inversely proportional to square of principal quantum number. Question may be asked in that way also. So yeah, this is a energy article. Also, we write E is equal to. So this m is constant, E is constant, 8, epsilon 0 and h square, everything is constant. If we substitute all the values and done the calculation, then it is coming, this minus sign as it is, then it is coming 13.6. And this n square I am writing as it is. This energy is in electron volt. So calculation we done, this is in electron volt. Okay? So we get this is the energy. Energy of electron is given by this formula, minus 13.6 divided by n square electron volt. If you want to find out energy of first orbit, substitute n is 1. So 1 square is 1, minus 13.6 electron volt is the energy of electron in first orbit. Similar manner, if you want to find out energy of electron in second orbit, then n is 2. So minus 13.6 divided by 2 square is 4. So it is coming 3.4 electron volt. Similar manner, you can find out energy of electron in any orbit by using this formula. So this is very important article. I hope everyone understood this and everything is visible. I hope everything is visible here. Take it. Hello everyone. From chapter 15, structure of atoms and nuclei. A new article is wave number. So what is wave number first? Wave number means a reciprocal of wavelength is called as wave number. Now here, whatever the formula we are getting here, this formula is useful to explain hydrogen spectrum here. So let me obtain that formula. So for this article, we must have previous knowledge of the energy of electron article. Means we require this energy of electron formula. Now here, by Bohr's third postulate, we know that third postulate is electron radiate energy when it jump from higher energy orbit to lower energy orbit, and energy radiated in the form of photon, and which is equal to the difference in the energies of two orbit. Now I consider that electron jump from nth orbit to inner orbit p. Then we can write energy radiated is equal to En minus Ep. So where En is energy of nth orbit, and that I can write it by formula me raised to 4 divided by 8 epsilon 0 square n square h square. So this is the formula me raised to 4 divided by 8 epsilon 0 square n square h square. Similar manner, I can write Ep minus me raised to 4 divided by 8 epsilon 0 square p square h square. So this I can write. So instead of n, I written here p. So let me substitute these two in equation number 1. Hence, equation 1 becomes. So E is equal to, I write this one, minus me raised to 4 divided by 8 epsilon 0 square n square h square minus this me raised to 4 divided by. So minus and this minus, so here plus 8 epsilon 0 square p square h square. Now after that we can take common from these two, and the common terms are me raised to 4, 8 epsilon 0 and h square. So minus No need to take minus common. So I directly write m e raised to 4. 8 epsilon 0 square h square 1 by minus 1 by n square plus 1 by p square. So these are the common terms. Now after that I can write here m e raised to 4 divided by, so this is e, 8 epsilon 0 square h square, in a bracket I can write 1 by p square minus 1 by n square. So this e I can write, I write it here, this e is h mu. So mu is a frequency, h is a Planck's constant. Now this h mu I can write hc by lambda. So frequency is c by lambda. C is the velocity of light and lambda is the wavelength. So by using that I have to write a formula of wave number. Wave number means basically 1 by lambda. So 1 by lambda we have to obtain, so transfer h and c to that side. Hence 1 by lambda is equal to m e raised to 4 divided by 8 epsilon 0 square, this c, and this h and h square is h cube. Then in a bracket 1 by p square minus 1 by n square. But here this m e raised to 4 divided by 8 epsilon 0 square c h cube, everything is constant and it is called as R, Rydberg's constant. Its value is fixed. So this is a Rydberg's constant. Hence I can write here 1 by lambda is equal to R, 1 by p square minus 1 by n square. So this is expression for wave number. So I hope everyone understood this. Now after that, this wave number, we have to use this formula to explain the hydrogen spectrum. Now pay attention here. When electron jump from outer orbit to inner orbit, then energy is radiated. Then if you find out the wavelength of that energy radiated, so we get a different range of the wavelength. As per that energy emitted, we can classify this into several, this energy is in the form of light. So basically, so if you find out the wavelength, then we get some light in the UV region, some in the visible region, some in infrared region. Based on that, we classified this series. So let's see a different spectral lines here. So when electron jump from outer orbit to inner orbit 1, then it is called as Lyman series. So I give the heading here, different spectral line, or so here we have some space here, so I write it here. So different spectral lines, and the first spectral line is Lyman series. Now Lyman series means what? When it is originated, when electron jump from outer orbit to inner orbit 1. So it means that here inner orbit is 1 and outer orbits are 2, 3, 4, 5 and so on. Now if I substitute here, hence 1 by lambda is R, in a bracket 1 by p square, p is fixed, 1 by 1 square, minus 1 by n square. N is having a different value. So n may be 2, n may be 3, 4, 5 and so on. If you find out the wavelength by using this 2, 3, 4, 5, these values of n, then we get a wavelength of UV light. So here we can write, so this, it lies in, this Lyman series lies in UV region. UV region of electromagnetic spectrum. UV region of electromagnetic spectrum. Okay. After that, second one, Balmer series. After Lyman, next one is a Balmer. Only the thing is here, electron jump from outer orbit to inner orbit too. So it means that here inner orbit is 2 and outer orbit is 3, 4, 5, 6, 7 up to infinity. Then we can write here 1 by lambda is equal to r 1 by n square, sorry 1 by p square, p is the 2, so 1 by 4 minus 1 by n square, n may be 3, 4, 5, 6, so on. If we substitute these values, we get a wavelength of visible light. So we can say that this Balmer series lies in visible region of electromagnetic spectrum. Lyman, Balmer, then after that Paschen. Third one is Paschen series. Paschen series. Now here P is 3 and N is 4, 5, 6, 7 and so on. Then if we find out the wavelength, so we can write by same formula, hence 1 by lambda is equal to R 1 by P square means 1 by 9 minus 1 by N square. After substituting the values of N, then it is coming in the infrared region. Infrared region of electromagnetic spectrum. Similar manner, the fourth one is Lyman, Balmer, Paschen, then fourth one is bracket series. Now here you remember in bracket P is now 4 and N is outer orbit. If inner orbit is 4, then the outer orbit is 5, 6, 7 and so on. So here P is 4 and N is 5, 6 and so on. Okay. Now we can find out the wavelength, and definitely this is also lying in the infrared region. Then last one is P fund. So P fund series, again here P is 5 and N is 6, 7, 8 and so on. These are the values of outer orbit. Now here we can draw a hydrogen energy level diagram by using this. So here different energy levels we get. So Lyman series, Balmer series, Paschen series, bracket series, P fund series. So let me draw energy level diagram by using this. So next is hydrogen energy level diagram. Hydrogen energy level diagram, or we can write energy spectrum for hydrogen atom. Now here I consider, here you can see this is visible now. So here N is 1. Now here I keep some gap and write here N is 2, second orbit. Then I am decreasing the gap here. N is 3. So again I am decreasing gap. N is 4. Now more less gap. N is 5. More less gaps. N is 6. And directly I am showing infinity here. So N is equal to infinity. Now this is first orbit. So energy is minus 13.6 electron volt. You know that energy of nth orbit is minus 13.6 divided by n square. This formula we already learned. Minus 13.6 by n square. By using that, if n is 1, this is the energy. If n is 2, then energy is minus 3.4 electron volt. If n is 3, then 13.6 by 9, so it is coming 1.54 electron volt minus, so everywhere. Energy of fourth orbit, so 13.6 divided by 4 square is 16, so it is 0.84 electron volt minus. Energy of fifth orbit, 13.6 divided by 25 and it is coming minus 0.54 electron volt and so on. Now here when electron jump from this second orbit to first orbit, third orbit to first orbit, fourth orbit to first orbit, infinity to first orbit. This is Lyman series. Lyman series, and it lies in UV region. Then second one, you know that, Balmer series. So when electron jump from outer orbit to inner orbit 2, so it is Balmer series. Visible region. Then third is Paschen series. When electron jump from outer orbit to inner orbit 3, then it is a Paschen series. Paschen series. It is in infrared region. Then outer orbit to orbit 4, then it is bracket series. And outer orbit to orbit 5, P-Fund series. So this is energy level diagram for hydrogen atom. So this diagram is asked in in board exam many times. So you have to remember this diagram. So hydrogen energy level diagram. See this diagram very carefully. This is very important. Now after that, limitations of Bohr's atomic model. Now here the first limitation. So Bohr's atomic model also having some limitation. First and very important is Bohr's model explain only hydrogen atom spectral lines. It explains only hydrogen spectrum. So it does not explain energy spectrum of other atoms. So this is a limitation. So no explanation for other atom energy spectrum. So this is first limitation. Second limitation is, so in Bohr's atomic model, so it is theoretically also not satisfactory, completely satisfactorily, because so here it is assumed that the electrons following particular conditions or atom following particular conditions are stable only. So this is a limitation here. So you know that in second postulate we learn electron does not radiate energy only when its angular momentum is integral multiple of h upon 2 pi. Similar manner here, when particular conditions are followed, that time only the atom is stable. Otherwise, means here this is one of the limitation of Bohr's atomic model. And the third limitation is here, if we see the spectral lines, so this is a hydrogen energy level diagram. So different spectral lines are there. The intensity of all the spectral lines are different from one another. In Bohr's atomic model, no explanation given for the intensities of spectral line. So this is also one of the limitation of Bohr's atomic model. Hello student. Today we start article from chapter number 15, atoms, molecules and nuclei. And it is law of radioactive decay. Basically it is related to the radioactivity. What is radioactivity? Basically radioactivity is the spontaneous emission of radiation from radioactive nuclei, and that is called as radioactivity. Basically radioactivity classified into three categories: alpha decay, beta decay, gamma decay, that we already learned in the previous session. Now we have to start a law of radioactive decay. So today's topic is law of radioactive decay. Now here, let I tell you mathematical statement, and then by using that you can write its statement. So mathematically dN by dt directly proportional to n. So this is a mathematical statement. Now in this formula where dN by dt is rate of disintegration, rate of radioactive disintegration at any instant, and here n is number of radioactive nuclei present at that instant, present at that instant. Then I told you what is dN by dt and what is n. So definitely you are able to write down the law of radioactive decay. This is directly proportional to this. So we can write the rate of radioactive disintegration at any instant is directly proportional to number of radioactive nuclei present at that instant. So this is a statement for law of radioactive decay. Now let's see. Let me learn this article further. Now here we can write the same formula. Hence dN by dt is equal to, now I am writing is equal to, dN by dt is equal to, I write constant here, minus lambda and n. So where this lambda is a constant and it is called as decay constant, where lambda is constant and it is called as decay constant. So lambda is decay constant. Minus sign. Minus sign is because this substance undergo decay, and because of that here I use minus sign. Now here, by using this we can obtain one additional formula which gives us number of radioactive substance present at that instant, and it is, so hence dN by dt is equal to minus lambda into n. I can transfer this dt to this side and n to this side. dN by n is equal to minus lambda into dt. Now integrating both sides. Integrating both sides. If we integrate both the sides, then what we get? So we get integration of dN by n is equal to minus lambda integration of dt. Now, as a mathematics student, you already know that integration of dN by n is a log of n. Log to the base e we are considering. You can write ln. ln means log of n is equal to minus lambda integration of dt is t plus c. So where c is constant of integration. Constant of integration. Now here, when I consider t is 0, when time is equal to 0, that time substance present is equal to the original substance, because we are considering the initial time when the disintegration not started. So when t is 0, then n is equal to n0. Now n0 is number of original substance present when the time is equal to 0. So n is equal to n0. Then, so I write here, hence log of n is equal to minus lambda t. So I have to substitute here these values. Instead of n, n0, I have to substitute log n0. Instead of t, 0. Minus lambda into 0, 0. Plus c. So we get value of c. Hence c is equal to how much? Log of n0. So we get value of c. So that we have to substitute in this equation. I can give here equation 1. Hence equation 1 becomes. Equation 1 becomes. I can write equation 1 by substituting the value of c. So log of n is equal to minus lambda t plus log of n0. So this equation we get. This log n0 we can transfer to this side. So here it is plus, to this side it is minus. So here log n minus log n0 is equal to minus lambda t. So this formula we get. Now after that, subtraction of log, it means that when we are solving a division, when we are applying a log to a division, then we get, means log of a divided by b is equal to log a minus log b. So here it's a subtraction, so I can write here like this way also, log of n divided by n0 by using a rules of logarithm. So minus lambda t. So this is log to the base e. I want to remove this log, so I can write here hence n divided by n0 is equal to, I can write here e raised to minus lambda t. Okay. Then after that I can transfer this n0 to that side. So we get, sorry, n is equal to, after transferring n0 to that side, e raised to minus lambda t. So this is the equation which gives us number of radioactive substance present at any instant t. Okay. By using this, we can conclude that radioactive decay is exponential decay. Therefore, radioactive decay is exponential. If we draw a graph, so let I draw a graph here. Graph of, this is time and this is number of substance present. So number of substance present on y-axis and time on x-axis. Now initially when time is 0, number of substance is equal to original substance. Here I can write n0. So this substance present, I can write it to this side, n0. Then as time passes, then substance decay exponentially. So here I can write, here it is n, then here time is t, then n minus dn when the time increases. So it may be n minus dn and the time is t plus dt. So I can write it like this way also. So this is t and this substance is n. Then after some time, so here it is n minus dn and here time is t plus dt you can write. So you can see this graph having an exponential nature. So therefore we can conclude that radioactive substance decay exponentially. I hope everyone understood this law of radioactive decay. Now we start new article, half-life time. So half-life time means what? So you know that when substance undergo decay, it decreases. Now here half-life time means time taken by that substance to decay half the original amount is called as half-life time. So I hope everyone understood what is half-life time. Time taken by substance to decay half the original amount is called as half-life time. Now we know formula n is equal to n0 e raised to minus lambda t, that we already proved, e raised to minus lambda t. When I consider when time is equal to half-life time, so let I represent half-life time by capital T. We can represent T 1 by 2 also. But for simplicity, I use a symbol capital T only, half-life time. Then n is equal to number of substance present is equal to original substance divided by 2. You know that when the time is half-life time, substances decay half the original amount. So n is equal to n0 by 2. Hence, we can write instead of n0 by 2 is equal to n0 as it is, e raised to minus lambda into this. Instead of small t, I have to write this half-life time, capital T. Now this n0 and this n0 get cancelled. So we can write 1 by 2 is equal to e raised to minus lambda t. The same equation I can write 1 by 2 is equal to 1 upon e raised to lambda t. Or we can write 2 is equal to e raised to lambda t. So I have to remove this e raised to lambda t. So I can write log of 2 is equal, this is log to the base e, 2 is equal to lambda t. So lambda t. So I have to write formula of t. Hence t is equal to this lambda is to this side divided to the log 2. Log 2 divided by lambda. But here log 2 is 0.693 divided by this lambda. and this is expression for half-life time. This is expression for half-life time. It means that here in half-life time substance decreases to half the original amount. So if I consider one more half-life time, means when time is half-life time, then substance is n by 2. Then after, when the original substance is n by 2 and one more half-life time I consider, then substance decay to n by 2 divided by 2, means n0 by 4. So that you can remember. If I consider 2 half-life time, then in 2 half-life time substance decay to n0 by 4, original amount divided by 4. In first n0 by 2, then again in one more n0 by 2. So we can write n0 by 4 in decay total. So I hope everyone understood this half-life time.